Welcome back to the video series on math revision made meticulous. Today, day 29, straight line in space from the topic three-dimensional geometry. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per day from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Let us see what is the equation of a straight line in space. There are 2 forms of equation. One will be a vector equation and another will be a Cartesian form. But you have to select which will be convenient to you. But suppose if you want to have all the formulae in Cartesian form, try to understand how to convert a vector into Cartesian. Let us first see the vector equation of a line. The vector equation of a straight line passing through a fixed point with position vector A and parallel to a given vector B. Therefore, for writing a vector equation of a line, we need 2 quantities. One is the position vector of a fixed point which lies on the line, and a parallel vector which is given by B. Then it is given by vector R is equal to A plus lambda into vector B. Here you are seeing 3 vectors. Vector A, already we have discussed, it is the position vector of the point on the line, and B is a parallel vector. And what is this R? This vector R is the position vector of a general point. Normally we will take general point as x, y, z. Therefore vector R will be xi plus yj plus zk. Then suppose if you go to the Cartesian equation, now in the same way we will go for here we are talking about the position vector of a fixed point. Here we will talk about the coordinate of the point. Therefore the Cartesian equation of a straight line passing through a fixed point x1, y1, z1 and having direction ratios proportional to ABC. There we were talking about a parallel vector. Here we are talking about the direction ratios ABC. There it will be x minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C, where x1, y1, z1 in the numerator talks about the point. The numbers in the denominator ABC talks about the direction ratio, where the line is having direction ratios proportional to ABC. Or you can directly assume that these ABC are the direction ratios of the given line. In 2 dimension, we always talk about the slope of a line in the equation of a line. Here in 3 dimension, in the equation of a line, we are talking about the direction ratios. Now, we should know how to convert a vector equation into Cartesian and Cartesian into vector. For example, I take a vector equation like this. Vector R is equal to I minus 2j plus 3k plus lambda into I plus 2j minus k. Be careful. This is the general form. There will be a vector in the first place plus lambda. Suppose if it is given as minus lambda, it should be converted into plus lambda only. First vector plus lambda into second vector. Already we have discussed the vector which is in the first place is the position vector of a point, and the vector which is got multiplied by lambda is the vector which is parallel. Therefore position vector of the point is I minus 2j plus 3k. Therefore parallel vector to the line is I plus 2j minus k. That is a vector which is in the second place. So from this, can I get the point? Yes, I can get the point. The point will be 1 minus 2, 3. I minus 2j plus 3k, therefore 1 minus 2, 3. Then what will happen to the direction ratio now? It is nothing but the components in the parallel vector 1, 2, minus 1. Now I got a fixed point and direction ratio. I am going to write the equation now. X minus the first point x minus 1 by 1 is equal to y minus of minus 2 by 2 is equal to z minus 3 by minus 1. Check out in the numerator the point coordinates. X coordinate, y coordinate, z coordinate will come. In the denominator the direction ratios will come. Or you can write like this. But remember, this equation which we are talking about, x minus 1 by 1 is equal to y plus 2 by 2 is equal to z minus 3 by minus 1 is called the standard form of equation of a line in Cartesian form. Now you can think about the other way also. Suppose if you are given a Cartesian equation, then from the numerator you can get the point, from the denominator you can get the direction ratios, and you can write the vector equation as vector r is equal to point vector plus lambda into the direction ratio vector. But you have to be very careful. The equation of the line which we are talking about now in Cartesian form is the symmetric form. It is symmetric, it is called a symmetric form. Therefore, the equation of the line in symmetric form of the line in Cartesian form is expressed in symmetric form to identify the point and direction ratios of the line. But you have to write it in symmetric form only, then only you can identify the point and direction ratios. Can you visualize it in the symmetric point? You have to remember one important thing in the symmetric form: coefficient of x, coefficient of y, and coefficient of z all are plus 1. It is x minus x1, y minus y1, z minus z1. If it is there something other than this, you have to convert it. Then you have to identify the point and direction ratios of the line so that we can proceed further. Let us move on to the next idea. The coordinate of any general point on a line, we want to find it. In 2 dimension also, whenever the equation of a line is given, we will try to find more points on it. Here, from the equation of a line in symmetric form or Cartesian form or even in vector form also, we will be able to identify one point directly. Here, one point is x1, y1, z1. How to get more points? Equate it to lambda because this is in symmetric form. Now do simply take x minus x1 is equal to a is equal to lambda, get the value of x. Y minus y1 is by b is equal to lambda, get the value of y. Z minus z1 is equal to c, get the value of z. Now you will get first x coordinate x1 plus a lambda, y coordinate y plus b lambda, z1 plus c lambda. Here what is advantage? We know x1 a, y1 b, z1 c. Then by going on by putting so many values for lambda, lambda is equal to 1, lambda is equal to 2, lambda is equal to 3, lambda is equal to minus 1, lambda is equal to minus 2. You can go on putting the value for lambda, you will get infinite number of points on the line. Therefore, to get the general point, equate the given line to lambda. But remember, whatever you are doing, check out that the given line is written in the symmetric form, which is the general form of the symmetric form. You should be very careful. Okay, bye. Let us move on to the next idea. In 2 dimensions, we know how to get the slope of a line when you know 2 points. In the same way, in 3 dimension, we can find the direction ratio of a straight line passing through 2 fixed points x1, y1, z1, x2, y2, z2, given by x2 minus x1, y2 minus y1 and z2 minus z1. Here you should be very careful. You should use the same direction. x2 minus x1 means then next one should be y2 minus y1 only. Next one should be z2 minus z1. As it is a direction ratio, after you are doing the subtractions and then getting the direction ratio, you can simplify it also. Well, now using this, we are going for the next idea. The Cartesian equation of a straight line passing through 2 fixed points is given by x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. Actually, this is a very interesting idea. You know that the numerator contains the point, denominator contains the direction ratio. When 2 points are known, we are finding the direction ratio and putting it in the denominator. Let us move on to questions now. Now, for question number 1, you have been given a Cartesian equation of a line is 6x minus 2, 3y plus 1 is equal to 2z minus 2. You have to find the direction ratios and vector equation of the line. Check out, is it the given equation is in standard form? No. The Cartesian equation is given. The equation is not in symmetric form. How to convert it into symmetric form? Keep it in mind. Coefficient of x, y, z should be plus 1. From the first one, take 6 outside, 3 outside and 2 outside. It will become 6 into x minus 3 by 6, 3 into y plus 1 by 3 and 2 into z minus 1. Now, how to write it? Whatever the number there, that should come in the denominator to identify the direction ratio. Therefore, it will be x minus 1 by 2 by 1 by 6 equal y plus 1 by 3 by 1 by 3 is equal to z minus 1 by 1 by 2. For I am taking this equation once again. This is a general equation. X minus x1 by a, y minus y1 by b is equal to z minus z1 by c. Now identify it now. The fixed point is 1 by 2, minus 1 by 3 and 1. Then what are the direction ratios? 1 by 6 is to 1 by 3 is to 1 by 2. You can leave it as it is, but you can write it like this also. By multiplying throughout by 6, it will become 1 is to 2 is to 3. by multiplying throughout by 6 or taking LCM as 6, whatever you want. Now you got a fixed point and you got a direction ratio. Then how to write the vector form? Vector R is equal to the vector obtained from the point, that is a position vector of the point, 1 by 2i minus 1 by 3j plus k plus lambda into the vector obtained from the direction ratios 1, 2, 3 for I plus 2j plus 3k. Now you identify it, how to write a Cartesian equation into vector, how to convert a vector into Cartesian. Go to question number 2. Find the Cartesian equation of a line passing through 2 points, also reduce its vector form. We have been given 2 points now. We know how to get the equation of a line when 2 points are given. X minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. Let us apply it now. It will be x minus 2 by 4 minus 2, y minus of minus 1 by 2 minus of minus 1, z minus 3 by 1 minus 3. Now I have used the first point to construct this equation. You can use any point there. For x minus 2 by 2 is equal to y plus 1 by 3 is equal to z minus 3 by minus 2. This is the equation. Let us continue. Now from this, are you able to find the fixed point? Yes, it is given in the question itself. 2, 1 minus 1, 3. And I have identified the direction ratios 2, 3 minus 2. Then how to write the equation in vector form? Vector R is equal to the vector position vector of the point, that is 2i minus j plus 3k plus lambda into the vector obtained from the direction ratio 2i plus 3j minus 2k. You always remember like this. It will be very easy for you to do the conversion from Cartesian to vector, vector to Cartesian. Let us move on to question number 3. Here you have been asked to show that 3 given points are collinear. We have used this to get the collinearity. We have used several methods, but when they are collinear, they lie on a line. Here we are going to find the equation of the line also. Show that the points A, B, C are collinear and find the equation of the line containing the collinear points. Here we will use the idea that the direction ratios idea, then we will use the parallel nature idea, then we will go for the equation of the line. The direction ratios of a straight line passing through 2 fixed points already we have seen. It will be x2 minus x1, y2 minus y1, z2 minus z1. Let us find the direction ratio of AB. It will be minus 3, minus 1, minus 4. Now I can write it as 3 is to 1 is to 4. Similarly, let us find the direction ratio of BC. It will be 9 is to 3 is to 12. I can write it as 3 is to 1 is to 4 by dividing throughout by 3. We are doing it only to compare the direction ratio of AB and direction ratio of BC. Now we got the direction ratios of AB and BC now. Both are equal. Therefore the lines are parallel, but they are having a common point B. Therefore the points are collinear. Now for collinearity can be proved by making use of this idea only, making use of direction ratios. But now we have to find the equation of the line containing them. It is very simple. We have a fixed point. You can take any point, either A or B or C. Minus 1, 3, 2, and direction ratios already we have obtained as 3, 1, 4. Therefore it will be x minus of minus 1, therefore x plus 1 by 3, y minus 3 by 1 and z minus 4 by 4. Here the thing is that collinearity, if it is asked, it can be proved in any fashion, but you have been asked to find the equation of the line also. Therefore we are using the direction ratios idea. Get the direction ratio of AB and BC or AB and AC, prove that they will be equal. They are having a common point, therefore collinear, and you can write the equation of the line containing them. Let us move on to question number 4. We have to find the point of intersection of the lines. Normally we will be doing it in 2 dimension also by solving it. Here let us see how to do it. Now we will take a general point from the first line. You know how to do it. Equate it to lambda. You will get 2 lambda plus 1, 3 lambda plus 2 and 4 lambda plus 3. Again take the second equation also and equate it to mu. Then it will become 5 mu plus 4, 2 mu plus 1 and mu minus 0. Whenever we are taking any general point in 3 dimension, the technique is we will call that general point as the point which we are seeking, which we are searching. Suppose if it is the foot of the perpendicular, we will call the general point as the foot of the perpendicular. Suppose here we want to find the point of intersection. Therefore let us assume that this general point is the point of intersection. What do you mean by point of intersection? Then these 2 points should be equal. All of you know what is the meaning of point of intersection. Therefore 2 lambda plus 1, 3 lambda plus 2, 4 lambda plus 3. That is the general point of the first line is equal to general point of the second line. Now we got equations now by simply equating, and from the first equation I got 2 lambda minus 5 mu is equal to 3. From the second equation I got 5 lambda minus 2 mu is equal to minus 1. Third equation 4 lambda minus mu is equal to minus 3. Here you got 3 equations in 2 variables where you can solve it very quickly. Now I got the first equation multiplied by 2. Take the last equation and you subtract it, you will get minus 9 mu is equal to 9, therefore mu is equal to minus 1. Take the second equation, put mu is equal to minus 1 and you will get lambda is equal to minus 1. For when lambda is equal to minus 1 and mu is equal to minus 1, put it either in the first one or the second one. I think you put lambda is equal to minus 1 in the first or mu is equal to minus 1 in the second. You will get the point of intersection as minus 1, minus 1, minus 1. Very, very interesting. Now how to get the point of intersection? Get a general point from the first, get a general point from the second and equate it and solve it. Now let us move on to angle between two lines. Already we have seen it in vector algebra also, angle between two vectors, the same thing. Here we have to identify the direction ratios of the first line. First line direction ratio A1, B1, C1. Second direction ratio A2, B2, C2. Please be careful, these direction ratios are to be identified after converting the line into general form or symmetric form. Then cos theta is equal to A1, A2 plus B1, B2 plus C1, C2 divided by square root of the sum of the squares of the direction ratio of the first line multiplied by sum of the squares of the direction ratio of the second line. Now from this, all of you know when they are parallel what will happen? The direction ratios will be proportional. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. In 2 dimension, we used to tell that when two lines are parallel, the slopes are equal. But in 3 dimension, when the two lines are parallel, then the direction ratios are proportional. Then if the lines are perpendicular, all of you know cos theta will become cos pi by 2. Therefore, numerator will become 0. A1, A2 plus B1, B2 plus C1, C2 is equal to 0. For when the perpendicularity idea is given in the question, you have to multiply their corresponding direction ratios, product of the corresponding direction ratios, sum of product of the corresponding direction ratios is equal to 0. Once again be careful, direction ratios are to be identified after writing the given equation in symmetric general form. Good. Now let us go to question number 5. Two lines are given perpendicular, find the value of lambda. This type of question, very common question. But before you start the question, be careful whether the given lines are in standard form. Perfect. First line is x minus 1 by minus 3, y minus 2 by 2 lambda, z minus 3 by 2. Second line x minus 1 by 3 lambda, y minus 1 upon 1, z minus 6 by minus 5. Perfect. Therefore, no need to worry. Now this, be careful, coefficient of x, y, z in both the equation is plus 1. Suppose in the question if they have given 1 minus x by 3, you have to convert it into x minus 1 by minus 3. Be careful. Good. Now let us go out to the question now. These are the given line. We know that they are perpendicular if the product of sum of the product of the direction ratios minus 3 into 3 lambda plus 2 lambda into 1 plus 2 into minus 5 is equal to 0. Therefore, I got minus 9 lambda plus 2 lambda minus 10 is equal to 0. Minus 7 lambda is equal to 10. Therefore, lambda is equal to minus 7 by 10. Very simple question, but be careful after checking whether the given lines are in standard form, then identify the direction ratios, then apply the condition. Well, success is dependent on efforts. All the best and thank you.